So we've already looked at finding the area underneath one curve. But what about finding the area in between two curves? Well, side note, if I said, what is the difference between 12 and 7? Meaning, what is in between 12 and 7? Well, you would go the big one minus the small one, and you would get 5. So you want the big minus the small to be able to get your answer. Same idea works here. If you're looking for the area between the two curves, you want to take the total area, the big area, minus the area underneath your smaller curve, the small area, to be able to get the area in between your two curves. So you do the integral of the big function minus the small function, is really what it boils down to. So if you have g always being smaller than f on a closed interval, your area between the two curves would be the integral of f minus g from a to b. In general, it's always the top function minus the bottom function, big minus small. So, looking down here, we have our parabola, we have our diagonal line. We need to find our area in between these two functions from 0 to 1. So we need to do the top function, which is our parabola, minus our bottom function, which is our diagonal line, from 0 to 1. So those would be our bounds. Well, we could easily go ahead and integrate this. We get a 1/3 x cubed plus a 2x. And you might be wondering, where does that come from? Well, we have a plus x right here, and you integrate 1x, and you get x squared over 2. And then you just have to plug in 1, subtract what you get when you plug in 0. Well, if you plug in 1, you get this. Subtract what you get when you plug in 0. That's subtracting 0 doesn't change it, so we just get 17 over 6. So here we have another parabola, and we have another line. We can do the same thing. We can do the top function, which is our parabola, minus our bottom function, which is our diagonal line. However, we got to figure out where the parabola and the line cross each other so we know our bounds. Well, isn't that where they're equal? Well, if they both equal y, we should be able to set these equal to each other. Well, now it's just a quadratic function, so we can set it equal to 0 and solve it. Factors quite nicely, set each parenthesis equal to 0. So the crosses over here when x is -3, crosses over here when x is 2. Those are our bounds, so we integrate from -3 to 2. So all we have to do at this point is to go ahead and integrate and then evaluate. Integrate your 6, you get 6x. Integrate your x squared, you get a 1/3 x cubed. Integrate your x, you get a 1/2 x squared, and then you have to evaluate it. So plug in your 2 minus what you get when you plug in 1, and you would get this. And by the way, this random x should not be there. Sorry about that. Now, what I would probably do is I would type this whole line in all at once on my handy dandy calculator to have it just spit out this as a fraction. I would not try to work it out individually. Now, suppose we have this problem here. Once again, we have a parabola and we have a line, except it's a sideways parabola. And we have our diagonal line. Now, what we were doing before, we always had one function on top and one function on the bottom. You'll notice in this section right here, we have the red line diagonal line on top, we have the parabola on the bottom. But in this section over here, we have the top half of the parabola on top and the bottom half of the parabola on the bottom. Since we don't always have one function on top and one function on the bottom, we have to break it apart into two integrals. We'll have to do one integral where we have our diagonal line on top, which is our 1/2 x squared, and our parabola on the bottom. And that goes from -8 all the way over to 4 where they meet. Now, since we're dealing with x, we really have to go ahead and try to get this x by itself. If you solve this for x, that's where we get, or not solve it for x, solve it for y, that's where we get this. Now, it's technically plus or minus, so we know we're dealing with the bottom half of your parabola, so you know it's the negative root. Well, over here, you still have to have it solved for y. You'd have the top half of your parabola, which would be the positive root, and then you'd have the bottom half, which would be the negative root, and you'd be integrating it from your 4 all the way over to 8. So we'd still go top minus bottom, but as two separate integrals. So we'd go from 4 to, or -8 to 4, the top function, which is our diagonal line, minus our bottom function, which is our negative root of our parabola. And then you'd have to add in your other one, which starts at 4, goes all the way to 8. Your top half of your parabola, your top part, minus the bottom part, which is the negative root. So we could simplify just a little bit. Minus and minus is plus. Write it as a fractional exponent. And then over here, you had to have this root plus that same root again, which really gives you 2 of those roots. And then once again, writing your root as a fractional exponent. All you have to do at this point is to integrate. Increase your exponent by 1, have to undo your exponent in front, and then you have to undo the chain rule, so it gives you a negative 2/3 in front, because the derivative of the inside is -1. And then evaluate it from -8 to 4. Same type of thing here. We have to go ahead and increase your exponent by 1. Undo the inside, which is a -1. So you'd have to have a 2/3 in front to offset your exponent, but that 2/3 with that 2 in front, that's where the 4/3 come from. And you'd have to evaluate it, plugging in your 8 minus what you get when you plug in 4. So over here, you plug in your 4, minus what you get when you plug in -8. And then over here, you'd plug in your 8, minus what you get when you plug in 4, and you get 36. So I would probably plug this whole line into my calculator at once, and whether you simplified it a little bit like I did before you plugged it in, or just plugged in your 4 in both spots as you saw it, and then your -8, wouldn't really make a difference. Now, just like we've been doing big function minus small function, and when you're going up and down, big is on top, small is on the bottom. Well, it even works if you're going sideways, except if you're going sideways, your big would be what's on the right, and your small would be what's on the left, because when you're going left and right, what's on the right is big, what's on the left is small. Just think of a number line. Except when you're going right minus left, you're dealing with your y. So you'd be integrating with respect to y rather than x. So in other words, your right function, your left function here needs to be in terms of y's. And this should be italicized. So just be aware of that. So if we go back to that last problem, you notice there's always one function on the right, which is your parabola, and always one function on the left, which is your line. We could have done this last problem just as one integral dealing with your parabola on the right minus your line on the left. So subtract your line. Now we did have, remember, it was y is equal to a 1/2 x, but because we're dealing with y's, we got to go ahead and get x by itself. You got to subtract this. That's why we have this here. Then you'd want to subtract what your right function is the parabola, which is this. Oh, but now we're dealing with y's, so your bounds have to be y's. Well, your bounds and your y's, your one y values here, your other y values here. So your shaded region starts at -4, goes all the way up to +2, so that's what your bounds are. Well, all we have to do is integrate. That's pretty easy to integrate. You get an 8y minus a 1/3 y cubed minus a y squared. Evaluate that from here to here. So plug in your negative, or plug in your 2 minus what you get when you plug in -4. And then I would probably just type this all into my calculator at once, or you can do it by hand. Either way, you still get 36, which is good because it's the same problem we just did, so you should get the same answer. So if you're going sideways, remember it's right minus left and you're dealing with y's. If you're going up and down, top minus bottom, and you're dealing with x's. So here we're trying to find the region between this graph and this one over here. So in other words, we have a cubic function and we have a parabola. Well, if you look at your graph, you'll notice in this region here, your cubic is on the top and your parabola is on the bottom. But when you look at this region over here, your parabola is on the top, your cubic's on the bottom. So we're going to have to do two separate integrals. So first of all, you got to figure out where they cross. Well, we have a nice graph. You can easily see where they cross. Suppose you didn't know where they crossed from looking at a nice graph like this. Well, you have your parabola, set it equal to your cubic. And then all you'd have to do is solve that. Set it equal to 0. You could add an x squared to both sides. They drop. Subtract a 2x from both sides. Now you could factor. Pull out a 3x. And then you'd have an x squared minus 4, which is differences of squares. So you get a 0, a 2, and a -2. Hey, that's good because it correlates to our graph for the x values of where our graphs cross each other. So we'd have to do one integral from -2 to 0 with the cubic on top, the parabola on the bottom. Oh, so we have to go our cubic on top and our parabola on the bottom. So the cubic minus the parabola on the bottom. Well, then we'd have to do this other one over here where the parabola is on the top and the cubic's on the bottom. And that goes from 0 to 2. Oh, 0 to 2. And we want the cubic or the parabola on the top. So 0 to 2 with the parabola on the top minus what's on the bottom, which is our cubic. Now, you could integrate it as it is, but I think it's going to be easier if you simplify and combine like terms after your integral sign in each case. So if we combine our like terms here, we get this. Combine our like terms over here, we get really the opposite of that, which should make sense because we switched the order in which you subtract. And if you go 12 minus 7 versus 7 minus 12, you get the opposite of each other. Well, in each case, these are pretty easy to integrate. You increase your exponent by 1, offset it in front. Increase your exponent by 1, have to evaluate it from -2 to 0. Add your other integral. Once again, increase your exponent by 1, plus increase your exponent by 1, and then evaluate it from 0 to 2. Plug in your 0. minus what you get when you plug in negative 2 plus, and then you got to do the other integral, plug in your 2, minus what you get when you plug in 0, and it all ends up being 24. So we're going to go ahead and look at this. This one's not too bad. You can see that we have one function on top, one function on the bottom. On your graph, you can see it's the red, which is your fraction thing, on top, and the blue, which is your parabola, on the bottom. However, if you set these equal to each other, if you take the red set it equal to the blue, there's no real easy way to solve this. What do we do? Oh, well, we know if we were working this out, we just have to do the red function minus this. But how do we get that upper bound? Well, here it says the upper bound is this. Oh, how the heck do you get that? Well, what I would do is I would put my first function into my y equals, put my second function into y1. I would maybe look at the graph of it. It looks like they cross right around 2. Once I have that, I would go ahead and have my calculator solve it. So I would hit Math, go down to Numeric Solver. Should bring up a screen like this. In equation 1, you want y1. So up here, remember, you got to go vars, arrow over to y vars, select y1. Then you go down here. You need to put in y2 because that's your second equation. Once again, go vars over to y vars, arrow down to y2, hit enter. Now, it should bring you to this screen here. It wants to know, where do you need to start looking? Well, from looking at your graph up here, it looks like they cross near 2, so that's why I put 2 right here. Now I need to hit solve. By the way, up here, once you get that typed in, you need to hit OK, which is in the same spot as your graph feature, or graph button. Once you type in your 2 here, you need to hit solve. So all you have to do is basically hit your graph button. And then if needed, hit solve again, but it tells you what x is. Okay? So how do you get that over there stored as A? Well, go to your home screen, hit your X button, and it should pull up this. Then hit your store button, which is left-hand side down by your on button, not your on button, but just above it. Hit your store button and then go A, which is your letters on your keyboard, so you have to use alpha. That's how you get what A is. So if we go back here, that's how you get A. Now, you know this last part's pretty easy to integrate. That's a 1/3 x cubed. So all we'd have to do is just integrate that. That's pretty easy to integrate. You're just integrating an x squared, a 1/3, increase your exponent by 1, and then you have to evaluate it from A to 0. Well, 1/3 times 1/3, you know, is a 1/9. So that's pretty easy to integrate. Now this first part, variables divided by variables, you might have to use a u. We're going to let u be what's inside the bottom. You get a du to be 2x dx. You'll notice for your problem you don't have a 2x showing up. So you could do this. If you wanted, you could pull your 7 in front, and then you could divide by 2 to get your dx. But either way, for the most part, it ends up being this. You know, you could put your 2 over 7 in front. You're integrating your u to the -3/2, so you increase your exponent by 1. To increase your exponent by 1, you get negative 1/2, so you got to have that negative 2 in front and then evaluate it. Now, technically speaking, when you switch it to u, you need to change your bounds to your u bounds. But we're going to switch it back here. Now, you could use your calculator, plug in this with your a value here, minus what you get when you plug in 0, minus, and do this, and you would get this here. Now, a second way you could have done this, you could have done through all this, but you could have used your calculator. So you could hit math down to your integration feature, still in that first column, right above your n-deriv, and it should pull this up. It's going to have a dotted box down here. That's where you arrow over, put 0. It's going to have a dotted box up here. You arrow up and you put in a. And then afterwards, once again, we're going to put our two functions. So you put our top function, which I had in y1, minus our y2, which was our bottom function, and we're integrating with respect to x, so you got to put x here, and it gives us the same answer. So you could do that.